Hi there, hope you are all doing great. Today let us learn about biostatistics. So before we go and dive into biostatistics, let us try to understand from a simple example. So there is an public health exam that is conducted and it is conducted for 100 marks. Alright? And there are only 10 students who have attempted it. So 100 marks exam it is. And there are 10 students who have attempted the exam. Now, for example, you have to present this marks to your superiors. All the 10 students marks, you have to present it to your superiors. How do you present them? There are two ways of presenting the achieved marks to your superior. The first way is that you just randomly give the numbers. So one student have got 30, one student 35, the other student have got 20, the other few students have got around 40 and few got around 60 and others got 75. So it is a random figure you're giving to your superior. Some random marks you're telling, ma'am, she got 30 like this. Now, there is this type of random representation of data is non-frequency type of data. Alright, so this is the non-frequency type of data. So there is other group of representation. How is that? So 35, 45, 45 and 45, 50, 50, 55, 55, 60 and 60. So this is the other way of representing data in a more accurate, self-explanatory way. So here what is it speaking? So as I have mentioned, it is 10 students who have written the exam. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10 students marks with their individual marks and number of occurrence, that is the frequency of that particular mark that have occurred among the 10 students. So 35 marks have occurred only once. 45 marks were gained by 3 students. 50 marks are gained by 2 students. 55 by 2 students and 60 by other 2 students. So we are representing the data in a well-mannered fashion and we are giving more information in a much more clear way to draw the conclusions in a better way. So we can tell, right, 50 was achieved by only 2 students. The highest score is only 60 and that too achieved by 2 students out of 10 students. So this is giving a better understanding of the data that is available. So that is the importance of biostatistics, dear students. So biostatistics will enable a researcher to gather the data and present it in a well-mannered way so that we can present the data in more tabular forms or pie charts, which will be more informative and better understanding. Other than that, the results of the research can be drawn by using the biostatistics. So now we have understood the data and there is some data which we have got out of the exam. Okay. Now, when there is a research that is done on particular sample, it has to be distributed, right? So there are 2 types of distributions here. There are 2 types of distributions. So the sample which we have got should be distributed in 2 ways. On a graph, if you take up a graph like this and if you think this is the center, okay, for example, take this is a center. And the sample what we have got, the complete set of data is falling 50% right side to the center and 50% left side to the center. So the data what we have got is distributed symmetrically away from the center. It is symmetrically distributed on either sides of the center. So such a symmetrical distribution on either side of the center is known as normal distribution. Okay, that is normal distribution and mostly it will be a bell-shaped curve. Alright, it's a bell-shaped curve. So the entire data is distributed equally and symmetrically on either sides of the center. Then only we can call it as normal distribution. Alright. So what is squeak distribution? That means here it is the center and the graph is continuing. So there is more number of data which is falling on the left side of the center. So for example, this is only 10% and this is going to be 90%. So this abnormal asymmetrical distribution of the data on either side of the center is known as squeak distribution. Alright. This is known as squeak distribution. So there are two types of distribution, normal distribution, squeak distribution. So this now in this type of distributions, we have something common, that is center. So in the particular data that is given, how do we recognize the center? So measuring the central tendency. How do we measure the central tendency for the given data? So the same curve, let us take a same curve and an approximate center. Alright. So to measure the central tendency in the given data, there are three types that we have to understand. Mean, median and mode. Alright, so mean, median and mode are the three measures of central tendency. Using these three parameters, we can find the central data set. So what was that? For example, if we are using the same marks achieved by those 10 students. What were they? So 35 plus 3 students got 45 if you remember. 45. 2 50s were there. 2 55s were there. And 2 60s were there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So sum of total observations is again number of total observations is 10, and we are adding each and every individual observation, each and every individual marks achieved by 10 students. So now this is coming around 500 by 10. So this sum is 500 divided by 10, that is 50. So 50. So here for that class example, it is 50. What is mean? Mean is 50 for this example. What is median for this example? Remember, dear students, whenever we are talking about median, the first thing you have to do is that you have to arrange the entire data what we have got in a particular magnitude. So here I have arranged the data what I have got in an increasing order. So 35, 45, 50, 55 and 60. So this is the increasing order arrangement that I have made here. So whenever you are dealing with median, if you want to derive the median, you have to first arrange in an order of magnitude the entire data what you have got. So there are two cases. There are some odd numbers and there are even number of outcomes. If there is an odd number of outcomes, then definitely there will be a single center that can be considered as median. But when you are dealing with an even number of outcomes, so if there are even number of outcomes, then how to deal with the center? So for example, 35 and here 60, 45 and 60 here goes, 45, 55. 45, 55. Now the center is left with 50 and 50. So the median for even numbers can be calculated by 50 plus 50 divided by 2. That is 100 by 2. That is 50. Again the median here is also 50. So the median here is also again 50. Now coming to the third parameter, that is mode. How do we derive mode out of this example? Mode is nothing but highest number of frequency of occurrence of the given data. So what is the highest frequency? Which marks are highest to the students? Like more number of students have got which mark? That is 45. 45 mark is achieved by 3 students. So the frequency of occurrence of this particular mark is highest, and that is considered as mode. So 45 is mode. So for this particular example, mean is 50, median is 50, and mode is 45. So this is the central tendency. So whenever there is an example where 50, 50 and 50, that means the mean, median and mode all are equal. So for example, there is some random scenario where mean, median and mode are equal. So such type of central tendency is there for some scenarios, and there you will get such a bell-shaped curve, bell-shaped symmetrical curve, and you can call it as normal distribution. Okay, only when mean, mode and median are equal to each other, you will get such a symmetrical normal distribution curve. So I hope you have understood the importance of data and its arrangement. And the next point we discussed is about the distributions, normal distribution and weak distributions, and how to measure the central tendency. Now that we have understood about the central tendency, research does not involve only the central set of data. Research also involves the data which is spread on either side of the center. Alright. So the data will be on either side also. So that is deviation. Okay. So that is deviation. So calculating how much amount of the sample is deviating from the center is also important. So the first point that you have to learn in deviation is standard deviation. So for example, consider 50 marks as your central tendency or mean. So 50. So here it is 10, 20, 30, 40 and 50. Then 60, 70, 80, 90 and 100. So keep it like this. So center is 50 now. So standard deviation, if it is less standard deviation, excuse me, your outcomes should be falling more closer to the center. If the deviation of the sample data is more closer to the center, it is less standard deviation. If the set of data is growing more away from the center, it is more standard deviation. Okay. So if it is less standard deviation, so it will be the data set will be very close to the center, which is more compact. Okay. So lesser standard deviations will show a greater compact in the research, and when the values are moving away from the center, indicating more standard deviation. Okay. So now, what is the range? How much they can spread out from the mean? How much they can spread out? So that is range. Range means the lowest value, which is 10, to the highest value. So highest value minus lowest value is 90. So this is the range. Means the deviation from the mean is at a range of 90. Okay. So this is a bigger range. So if the range decreases, if the range is decreasing, the distribution is coming closer. If the range is also if the range is increasing, means there is a wide range of distribution of the data set. There are at 10 marks there are some students, at 20 marks there are some students, at 30 marks there are some students. So it is like a wide range of distribution of the data set away from the center. That is what is the increase in range. So actually the range is the subtraction of the highest value from the lowest value will give you the range. And we have learned about the deviations. So we know about the central tendency and how much it is deviating. If it is if the sample data is deviating only the limited, it is less standard deviation. If it is deviating away from the center, it is more standard deviation. How much they can deviate, we give the given by the range. So topmost value minus smallest value will give you the range of that deviation. So standard deviation and range. So these are the measures of dispersion. These are measures of dispersion. Okay. So we have understood the measures of central tendency and measures of dispersion. Now, the other important area of biostatistics is tests of significance. Okay. So tests of significance. So this tests will tell us whether the given null hypothesis is true or false. Okay. So what are different tests of significance? They are parametric tests and non-parametric tests. So what are the two types of tests? Parametric tests and non-parametric type of tests. So first, let us try to understand parametric tests are done for a symmetrical data or normal distribution. When you have an MCQ saying that in somewhere in the question the distribution is normal, you have to give your answer related to parametric tests. This is how you have to listen. Okay, you have to understand. So symmetrical data and normal distribution of the sample, you will use parametric tests. When the data is non-symmetrical and it is weak distribution, you will be using non-parametric tests. And now, the next difference between parametric and non-parametric is that this will measure quantity such as, in numbers, number of students, age groups. It deals with quantity. Non-parametric test deals with quality parameters. So there is a quality parameter involved. So like we are taking online classes. So the type of class taken. So the quality parameters were dealt by non-parametric tests and quantity parameters were taken by parametric tests. The third is they will measure by metric values. Alright. They will measure by ordinal or nominal data. This is centimeters, meters, see quantities, numbers like this. Here ordinal or nominal data. What is nominal data? Nominal data means we can just name the data. For example, India, Pakistan, Afghanistan, America. So we can name the data. It is nominal data. What is ordinal data? We can rank them also. We can rank them depending upon the quality of education. We can rank India as number 1. So we are giving ranking. All right. So if we can give ranking, then it is along with the name. It is ordinal data. We can give only names to the data. It is nominal data. Alright. So this is the difference between parametric and non-parametric. Here we will deal with deal with percentages and proportions. Okay. Whenever there is a percentage or proportion, here there are simple numbers. Okay, when we are dealing with percentages and proportions, if your question is asking something about some percentages, proportions were given in the question, you will apply a non-parametric test. And these parametric tests are highly efficient when compared to the non-parametric tests. They are highly effective. Effective is the right term to be used. So the parametric tests are highly effective. So let's revise once. The parametric tests were done in normal distribution. They analyzes more quantity and metric values and numbers. When it comes to the non-parametric, non-symmetrical, weak distributions measuring the qualities, ordinal and nominal data were used. Alright. So this is more effective when compared to non-parametric. Now, what are different types and examples of parametric and non-parametric tests? Coming to the examples of parametric and non-parametric tests. So the first example we all know is that paid t-test. Let me first write and then speak. Paid t-test, then unpaid t-test, ANOVA, analysis of variance, ANOVA, Pearson correlation coefficient. These are the main parametric tests. When it comes to non-parametric tests, we have signed rank test, Mann-Whitney U-test, and then we have chi-square test. Then we have Spearman's correlation coefficient. Okay. So now we are having some important parametric and non-parametric tests. In the parametric test, we have paid t-test. And this paid t-test is done, paid t-test is done to compare the means, okay, to compare the means within the same group. How do you compare the mean within the same group? Before and after. Means of before and after. Means of before and after within the same group gives paid t-test. Okay. So if there are the parametric type of research, so it involves more of quantities, more of metric values. So asymmetrical data, symmetrical data. So all these bring you a conclusion to parametrics. So such type of data which is normal distribution data dealing with metric systems, which is dealing with quantities, will come under parametric tests. And you want to compare before and after the means of before and after. Then you will choose paid t-test. Okay, paid t-test. Same, the non-parametric. So non-parametric means what are the things? There should be some quality, there should be some nominal or ordinal data that should be there. So when those type of researches are conducted, you will be assigning a non-parametric test. So signed rank test is given for the comparison of means before and after in a sample, in the same sample. So comparison of means in the same sample before and after is signed rank test and paid t-test. So both are same. Signed rank test and paid t-test. Both are same. Only difference is that this is parametric and this is non-parametric. And all also unpaid t-test, Mann-Whitney U-test, ANOVA test, chi-square test, Pearson's correlation coefficient, Spearman's correlation coefficient. So these are both the tests. So this test is same as this test. This test is same as this test. The only difference is these are applied to the parametrics and these are applied to the non-parametrics types. That's it. So now with that, if we are clear with that point, the next point is paid t-test and signed rank test is done for comparison of means within the same group, that is before and after. Unpaid t-test and Man-Whitney u-test. These are done to know the means, to know the difference between the means when there are two groups, not in the same group but within two groups. So when you are dealing with two different type of groups and you wanted to compare the means of two different type of groups, means of two different types of groups is done with unpaid t-test and Man-Whitney u-test. If the groups are increasing, there are 3 groups, 4 groups, 5 groups, there are more than 2 groups, you want to compare the means of more than 2 groups, then you will go with ANOVA or chi-square test. Most probably chi-square test is the best to approach. Okay. Then, so till here I think everybody is clear. What is this correlation coefficient? What is the correlation coefficient meaning? Correlation coefficient means, for example, there is temperature. For example, there is temperature and sales of ice cream. For example, there is temperature and sales of ice cream. If temperature is increasing, sales is increasing. So it's very hot. We obviously feel like eating and having an ice cream. So if there is a positive relationship, between rise in temperature and sales of ice cream. So this is known as positive correlation coefficient. So when we are comparing the relationship between the two entities, whether there is a positive relationship, they both are increasing, the both quantities or entities are increasing, that is positive. So what is negative? For example, there is a economy loss, there is economy that is not good in the country. So the gold rates will increase. With drop in economy, the gold rate is increasing. So that is the negative correlation. One entity is going down, one entity is increasing. That is a negative correlation. There will be something such as zero correlation also. There is no effect. For example, there is no effect of one entity on the other entity. So whether it is like there is no relation between the two entities. There is no relation. They will not increase or they will not decrease. There is no absolute relation between the two entities, growth or decline. So that is known as no relationship between the correlation. There is no correlation actually. So positive correlation, negative correlation, zero correlation. So this expression of the relationship between the two entities is given by correlation coefficient. If it is parametric, it is Pearson correlation coefficient. If it is non-parametric, it is Spear-Pearson's correlation coefficient. So these are the tests of significance. Now coming to the last aspect of the lecture, that is p-value. So coming to p-value, so probability value, probability of the null hypothesis proving to be correct or true is what is p-value. So null hypothesis is true. What is the probability of null hypothesis getting true is what is p-value basically. What is null hypothesis? What is null hypothesis? Basically, null hypothesis says that there is no difference between the two entities. Like there is no difference between the two entities in the research. So, for example, at the age of 25 to 35 years, for example, if you see, the mid-palatal suture is there. Mid-palatal suture. So, this is the mid-palatal suture. So, the research starts by a null hypothesis. Hypothesis means assumption. Null means there is no change, right? Null hypothesis is that, for example, if you take this example, 25 to 30 years is your sample. So there is the mid-palatal suture is the same before 25 and after 35. So you have taken a sample 20 to 25 and 30 to 40 years. So null hypothesis says that there is no change in the mid-palatal suture before and after 25 to 35, or before and after 35. We can say it like that. So there is no change before and after. So that is what is null hypothesis. Null means no change. Hypothesis is assumption. Now the p-value is nothing but how much times the null hypothesis can be proven true. So for example, it's a common example that we can every time see. If you can see this as a your laptop touchpad, okay? Your laptop touchpad, in your laptop touchpad, you can see there is a darkened zone here and there is light zone here. There is a high probability that we will touch that touchpad in the center. See here. And there is a very less probability of touching this edges. There is a high probability of touching the center. So if I touch my touchpad for 100 times, there is a chance of 80 times touching in the center. So here my p-value is 0.8. So if for example, you have studied somewhere, p-value is 0.8. So p-value is 0.8 means out of 100 times, if I repeat the same experiment or if I repeat the same action, out of 100 times, 80 times I have a chance of touching the center. So the p-value is 0.8 means the probability of getting the hypothesis true out of 100 is 80. If my p-value is 0.5 means out of 100 the probability is 50. If I repeat the same experiment for 100 times, the probability of me going with the true of hypothesis is 50. So now, at what value I have to consider the hypothesis? At what value, at what p-value, I have to consider the hypothesis as accepted or I have to reject the null hypothesis. That is determined by the level of significance. Level of significance. So the researcher at the initial stages of study will fix the level of significance. For example, the level of significance is 0.5. 0.5. The level of significance is fixed. Now, after the research, if your p-value is coming greater than 0.5, it may be 0.8, okay? So, any value greater than your level of significance, your null hypothesis is accepted. You got a p-value less than 0.5, maybe around 0.1, something like that, less than 0.5, 0.5, then your null hypothesis is rejected, okay? So, for the acceptance or rejection of the null hypothesis, p-value has to be considered. At the initial level of the research, the researcher should establish the level of significance. Any p-value greater than the level of significance, you can accept the null hypothesis. Any value less than the level of significance, your null hypothesis is rejected. Hope this is clear for you all. So these are the major concepts that you have to understand from the biostatistics. Thank you for watching with a lot of patience. Thank you so much.